basically at Cisco, Anup and myself went over this. So this is basically stemmed from the fact that we do a lot of optics validation, and we also have put a SPI-based test framework for automating the optics related validation and all. So one scenario we came across was the optics OIR, which is insertion and removal of the transceiver or pluggable or optics. So we did that manually, and it is working for various scenarios, but then we came across as to how to automate it. So this simulation of optics OIR stems from that fact. As we know that, like, to perform this physical operation of removal and insertion, we need to go to the lab or the data center, and the lab personnel or a technician has to do it manually, or whoever is validating, the developer or the validator. Now, in this proposal, we came up with a mechanism as to how to simulate this operation such that most of the software, almost all the software workflow gets exercised, which means anything at the platform layer, followed by anything in the NOS layer. With regards to the SONiC NOS, it means validating that when you do a removal of the optics, the relevant transceiver info table gets cleaned up, wiped out properly, and the link goes into operationally down state. Similarly, when we try to emulate or simulate the insertion, then at the SONiC NOS level, the required transceiver tables, the XCVRD gets initialized, those tables get populated, and the link eventually reaches operational upstate. So the benefit is apparent, meaning once we have this utility, one is able to make it a part of the automation test suite. So the mechanism we employed at the high level is something like at the board level, we have the GPIO pins for those transceiver which controls the presence and absence. So it's more like playing with those offsets and the registers to accomplish this task. So this is little more in the detail, but what we did at the utility or the mechanism level is we made it a Python script which will take the port number as the input where the optics is inserted and specify the operation, which is something like out for the removal, in for the insertion, and out-in for removal followed by insertion, which can further be refined with putting the proper gap between the removal and the insertion. For now, we have put it as a 2 seconds. So the table below shows some of the data at the board level as to how the mapping is done with respect to the GPIO, which is platform or board specific. So such things can come from a board YAML file or a platform YAML file, but the script or the higher level mechanism could still be generic. So these are some of the traces we tried capturing as part of this hackathon, which depicts as to how the flow was happening. And like I mentioned, checking the states on a removal, if you look at the bottom, checking the transceiver DOM sensor table, which is empty for the port in question. And also the other traces, which shows, okay, the port is operationally down when an out operation or a removal operation was performed. Similarly, when an in was performed, which is simulating the in at the GPIO level, so that entire software code is exercised, it eventually first it detects the optical pluggable module type, and then it brings up it to the operational upstate. And as you can see at the bottom, the Redis DB for that particular Ethernet port got populated with the right parameters. So this is more with regards to the improvement as to what we can do with respect to port recovery, error identification and all. But since it was a 2-day hackathon, so we haven't explored much into these areas. I think this is what it is, this whole thing about. Any questions?
Simulated? Oh. How is that the GPIO signal simulated?
So this is more like there are certain set of registers on the board or the schematic where you can do some kind of fit selection and insertion. So it's a combination of certain math with the logical GPIO pin numbers for that particular port, which simulates the kind of GPIO removal as if the pin has been detached from that optical module.
Okay, thank you. I think one question allowed. Yeah, thank you. Can you please stop sharing? Yeah.
Sure.